find the position vector of point R, okay, which divides the line joining 2 points P and Q, whose position vectors given externally. Please note that externally, whenever external division, then in the section formula, instead of plus, it comes minus. Okay, it comes minus that. In the ratio 1:2, also show that P is the midpoint of the line segment RQ. Okay, given that, first of all, external division. Okay, external division given 2:1. Given point R divides the line joining 2 points, divides the line joining points P and Q in ratio 1:2. 1:2 externally. Okay, externally. Okay, and also given position vector of point P and position vector of point Q. It means what is given also OP vector. Position vector of point P means OP vector is given 2A plus B vector. 2A vector plus B vector. Also position vector of point Q also given. OQ vector is A vector minus 3B vector. Okay. Then we have to find the position vector of point R. Position vector of point R means we have to find OR vector. Okay. Then OR vector. Okay. OR vector. Situation like this. It is P, it is Q, but external means R is somewhat here, outside. That's why external division. So here suppose P and here it is Q, it is R. Dividing in 1:2. So same concept. So this ratio then Q point, this ratio then P point. So according to external division, your answer will be ratio is 2, then position vector of point P. So it will be 2 into OP vector, then minus because of external division. 1 into position vector of Q, OQ vector divided by 2 minus 1. Okay, 2 minus 1. Okay, put value. OP vector is 2A plus B vector. So 2 into 2A vector plus B vector minus OQ vector is A vector minus 3B vector divided by 2 minus 1 is 1. Then 2 into 2, 4A vector plus 2B vector minus A vector plus 3B vector. So it is coming 4A minus A, 3A vector, 2B plus B, 5 vector. So first half is done. OR vector. First half is done. Not actually. First half is done. So next, I will draw one figure here. Q vector like this, P vector, Q vector, and here external division. This is R vector. Okay. RPQ. So we want to prove P is the midpoint of RQ vector. If P is the midpoint, it means we want to prove this 1:1 type. Then only P is the midpoint. No. If P is the midpoint of line segment PQ. Okay, then OP vector. Then OP vector must be 1:1. So 1 into OQ vector plus 1 into RP vector upon 1%. Then it is 1 into OQ vector plus 1 into OR vector and divide by 1 plus 1. So whatever answer in OP vector already we know. OP vector is 2A plus B. So this vector is 2A plus B. This vector is 2A plus B vector. If this answer also coming 2A plus B, then then we can say that P is the midpoint, otherwise not. Okay, and it will definitely come because we are seeing prove that. So 2A plus B, 1 into OQ vector will put OQ vector, this is OQ, A minus, because 1 into anything, so A minus 3B vector, okay, plus OR vector we have already found. What was OR vector? Please tell me. Last 3A plus 3A vector plus 5B vector and divide by 1 plus 1, 2. Simplify. A vector, 3A vector, 4A vector, 4A vector and plus 2B vector upon 2.
2A plus B vector.
Then it is divided by 2. So it is 2A vector plus B vector. Same coming down. Same. Yes, it is true. Hence proof. Okay. If P is the midpoint of the line segment PQ, then the following expression must be correct. And this is correct for me. Next question. Number 10. Yesterday, I not did this. Is it? Okay. Yes, it's your homework. This is A vector and this is B vector. Then what is the diagonal? Then what is its diagonal? Diagonal will be A plus B. A vector plus B vector. You can say this is A B C D parallelogram. A B C D parallelogram. So what is given here? I have assumed let A vector and B vector. Adjacent sides A vector. I am assuming the first one 2i minus 4j plus 5k. 2i minus 4j plus 5k. And the second one is I minus 2j minus 3k. Okay. So A vector given, B vector given. In the first half, find the unit vector parallel to its diagonal. So what is diagonal? A plus B. First of all, find A plus B. Then what is A plus B? Then its diagonal. A vector plus B vector. Just add it 2i plus I, 3i and minus 4 minus 2, 6j. Okay, plus 5 minus 3. Okay, it is a diagonal. And you want a vector, unit vector or simple vector? Unit vector, parallel to its diagonal. Okay, parallel to its diagonal, same vector. This vector. Then what is the unit vector parallel to its diagonal? A plus B divided by modulus. So the unit vector parallel to its diagonal. Okay. Can I say another name? Let's say C vector. No issue now. Equals to unit vector. I am saying n cap equals to C vector divided by mod of C. C vector value 3i minus 6j plus 2k divided by root over 3 square 9 36 and 4 root 49. So n cap is 49 is 7. So it is 36 for 49. Root of 49 is 7. So answer is 3 by 7 I cap minus 6 by 7 j cap plus. So this is first half. And then next line, also find its area. How to get area of parallelogram ABCD? Two adjacent side agreement. So mod of A cross B. Next, area of parallelogram ABCD. Area of parallelogram ABCD equals to mod of A cross B. Okay, you have to calculate this value, mod of A cross B. Then A cross B. Find it A cross B. I will come and check. I, J, Completed. 2 minus 4, 5, 1 minus 2, minus 3.
Yeah.
Minus 6.
Minus 5 plus 3 minus 4 plus 4.
12i plus 11 0.
22, sir.
22. I can add 22. 22. A cross B. If this is A cross B, then what is mod of A cross B? Then what is mod A cross B? Then magnitude of A cross B equals to root over 22 square plus 11 square plus 0 square. 22 square is 484 plus 121 plus 0. So answer is root over 605 square unit. Okay.
121 into
Okay. 121 into 5.
7.
And this is same as
121.
5 into
121.
121. So 121 square root is 11. It is 11 root 5. Okay. 11 root 5. Okay. 11 root 5. Thus, from 1, thus area 11 root 5 square unit. Question number 11. See, students, show that the direction cosines of a vector. Show that the direction cosines of a vector equally inclined. Inclination means angle. Alright, equally inclined to the axes OX, OY, OZ. OX means x-axis, positive x-axis. X-axis. OY is the y-axis, OZ, z-axis. Okay. Given that a vector is equally inclined to the OX, OY and OZ axis. It implies that alpha equals to beta equals to gamma. Okay, these are called direction angles. Okay, it implies alpha, beta, gamma. They are direction angles. Okay, and then their cosine, direction cosines. It implies direction angles are equal. Direction angles are equal. That is alpha equals to beta equals to gamma. Then what is L? Means cos alpha. And what is M? Means cos beta. But beta also is alpha. Beta is also alpha because they are equal. So I can write either cos alpha, cos alpha, cos alpha, or cos beta, cos beta, cos beta. Only one. And then M means cos gamma. But gamma is also alpha. It means it is cos alpha. And it is known that L square plus M square plus N square equals to 1. Okay? You write, we know that. We know that L square plus M square plus N square equals to 1. L means cos alpha, M means cos alpha, N means cos alpha. So it is cos square alpha plus cos square alpha plus cos square alpha equals to 1. Then 3 cos square alpha equals to 1. Then cos square alpha equals to 1 by 3. Then cos alpha, okay, plus or minus 1 by root 3. And cos alpha is what? Direction cosines. L. Then what is M? M is also cos alpha. So what are the direction cosines? plus minus 1 by root 3 comma plus minus 1 by root 3 comma plus minus 1 by root 3. Hence direction cosines. I told one shortcut for direction cosines, remember? DCS, direction cosines, shortening. Direction cosines are plus minus 1 by root 3 comma plus minus 1 by root 3 comma plus minus 1 by root 3. L M N. Okay, next 12. Let A vector, B vector and C vector. This, find a vector D which is perpendicular to both A and B and C dot D equals to 15. Oh, this question is somewhat lengthy, easy but lengthy. You know, whenever you are looking perpendicular vectors, if any two vectors perpendicular, then their dot product 0. Their dot product 0. And here A vector is given, whatever some A vector, and B vector is given, C vector is given. Find a vector D which is perpendicular to both A and B. It means you have to find such a vector such that D vector dot A vector must be 0 and D vector dot B vector must be 0 and C dot D vector must be 15. Where C is this? So such vector we have to search it. Let D vector equals to D1 I cap plus D2 J cap plus D3 K cap. This I assumed, okay? I have to find D1 and D2 and D3 by using the given information. We have this information: A vector given, B vector given, C vector given. If D vector is the required vector, then first condition, it is perpendicular to A. It implies that D vector dot A vector equals to 0. Correct? And this is perpendicular to B vector and D vector dot B vector equals to 0 and C vector dot D vector equals to 15. Okay, you know D vector is D1I plus D2J plus D3K. From here, can you tell me what is D dot A product? Here, what is the component of A vector? 1, 4, 2, and here 3, -2, 7. So directly see and tell me. I don't want to write everything. Already question is lengthy. So it will be 1 into D1 plus 4 D2 and plus 2 D3 equals to 0. This is equation 1. 1 already I have written. So this is equation suppose 2. Now D dot B vector. D dot B vector is what? D1 into 2, 3. So it will be from here I can write 3 D1 plus minus 2 D2 plus 7 D3 equals to 0. Equation number 3. And one equation from here. C dot D vector. C dot D vector. C vector is given there. So it will be 2 D1 minus D2 plus 4 D3 equals to 15. I thought again 0. Okay, what is this? This is the system of equation. Now this question of determinant. A1 plus 4B1 plus 2C1. Solve for D1, D2, D3. This question of determinant. Now we have to solve for D1, D2, D3. Okay. So if I say write little bit, let me write A into D equals to A into X equals to B. Okay, what is A? A is 1, 4, 2. A is a coefficient matrix. 1, 4, 2. 3 minus 2, 7. And 2 minus 1, 4. And what is capital X? D1, D2, D3. What is capital B? 0, 0. Okay. Then we need det A. Det A, can you tell me what is det A? Chalo. 1 minus 8 plus 7, correct? Minus 4. Then 12 minus 14. Yes. Then minus 3 plus 4, correct? Minus 3. You also do your calculation. If suppose here something is wrong, you can inform me. Don't believe me blindly. Here. Okay. What is the answer? Final answer, students? Minus 8 plus 7, minus 1, and from here, minus 2 into plus 8, and here 4, 3, 1, 2, plus 2, plus 8 plus 2, and minus 1. Plus 9. So answer is plus 9. You also said, are you getting 9? Correct. Okay. Correct. Okay. After that, adjoint. A inverse. But for A inverse, adjoint required. Tell me adjoint required for that. Adjoint. Okay. Can I do direct shortcut method for adjoint? Huh? Can I do shortcut method? So it is 1, 4, 2, 1, 4, 2, 1, 4, 2. This will be our upper. Okay, this side. I will write direct adjoint. That examiner will be solved how this person has written direct adjoint. He don't know what I know, what we know. So it is 1, 4, 2, 1, 4, 2, and then 3 minus 2, 7. After that, 2 minus 1, 4. Do you remember shortcut method? First repeat two columns. We have to repeat first two columns. 1, 3, 2, minus 4, plus 4, minus 2, and minus 1. Then I need to repeat first two rows. So change the color. 1, 4, 2, 1, 4. 3 minus 2, 7, 3 minus 2. Then what next? We have to delete this, forget this, useless. Now write here adjoint direct. I will calculate column wise and I will write row wise. So 4 into minus 2, 4 into minus 2, minus 8 and plus 7. How much? Minus 1. Minus 1 plus 1. Minus 1 coming? Yes, minus 1. Then next one, 2 into this and this element. 2 into minus 1, minus 2 and minus 8, minus 10, minus 10. This is revision also for adjoint. Then this into this, 7 into 4, 28 and 2, 2, minus 4, 28 plus 4, 30, 30, okay. Then this multiply, 2 into 7, 14 minus 12, 14 minus 12, 2. Okay. 4 minus 4, 0. And it is 3. 6 minus 7. 6 minus 7 minus 1. Okay. Then this. Minus 3 plus 4. Minus 3. Minus 3 plus 4. Okay. 8 plus 1. 1 into 1. This minus 1. 9. Okay. Then minus 2 minus 12 minus 14. Adjoint we got. Then what is A inverse? Okay. 1 by 9 into this minus 1 minus 10 32 2 0 minus 1 1 9 and minus 14. Okay. Then Ax equals to B given, equation number 5. Then from 5, what is x? A inverse into B. A inverse value is this. B value is 0 0 15. Then you will get your x value d1 d2 d3, and after putting in equation 1 you will get the required vector. Okay, because I need now space. Please minutes. So capital X is D1,
D1,
D2, D3, and A inverse is 1 upon 9, 1 upon 9, minus 1, minus 10, 32, 2, 0, minus 1, and 1, 9, minus 14, and B is 0, 0, 15. Okay, don't send 1 upon 9 inside, just first multiply. 1 upon 9,
minus 1 by 3.
okay. So first 0 plus 0 and 32 into 15. 32 into 15. This 0 plus 0, 32 into 15. How much? Multiply.
480.
How much?
480.
480. Then 2 into 0, 0 plus 0 into 0, 0, and minus 1 into 15, minus 15. Okay. Then again 0, 0, minus 14 into 15. 210.
210.
210. Okay. Now 480 upon 9. D1, D2, D3. 480 by 9. We can cancel 3 3s are 9. 3 1s are 3. And 3 6 are 18. 160 by 3. 160 by 3. And minus 15. 3 5s are 15. And 3 3s are 9. Again 3 7s are 21. Minus 7 t by 3. So D1 is 160 by 3, D2 is minus 5 by 3, D3 is minus 70 by 3. You can check the answer. Hence the required vector. Now check answer. Hence, okay, D vector equals to 160 by 3 I cap minus 5 by 3 J cap and minus 70 by 3 K cap. Answer statement? Is it same?
But 1 by 3 common. Same answer.